Actually, it wasn't.
fishing.
I'm like putting together slides about Seaborn, like data visualization, and it's like pulling teeth because I'm not a data visualization guy. So, oh my
You didn't.
goodness, we're twins, aren't we? Ah,
I saw your hat,
you had to like
and I was
look at
like,
that.
I literally
Chris
just
isn't
looked at
part of the.
mine. Is of course has been faded.
Yeah, mine is brand new from this summer. So
My Browning hat is in another room, and I don't want to get up and go get it. So
Eh, well, these are Hornady hats.
I
So
know that,
I don't
but
even.
that's the
I
closest that I
literally.
have.
What do they sell?
Ammo.
Hornady ammo.
I literally it was on a table and it was free, and I'm like,
Yeah,
okay, hat.
no, they're good. But they're great hats. I have a one of my students that actually works at Hornady, and he's like, "Hey, I have this extra hat. You want it?"
Is that
Yeah, I love
free? Is
hats.
that a
It
freebie,
was free. It was,
Chris?
Yeah, this was my
Oh,
free for spending about $3,000 at
oh,
Shields.
jeez.
Like, oh yeah, pick something from the prize wall.
For
Okay, I got
free.
a
Yeah.
free $9 hat for spending $2,500.
Wow, you got $9 for 2,500. That's pretty good. Pretty
I
good
well,
return
no,
on
it was
investment.
closer to three. I splurged on my. I upgraded my protection piece. We'll say I
Uh-huh.
got a staccato.
Nice. Which is closer to 3,000.
It's about 25,
But
all said and done.
you have a
It's a
new
forever gun. That's why I
yes,
got it.
it's nice. But you have a new hat to wear it with, right?
Right. That is my like everyday, crap hat. I have good hats that I wear when I care about what I look like, and crap hats when I don't.
All right. I can kind of wear this out in, decent places kind of hat because it's not all stained and grody with my sweat and dirt and all that kind of stuff.
I literally wear mine wherever I go. I don't even care.
Yeah. During the
You're just
summer,
above
yeah,
us, man.
mine are just junk. Like they're so I have the one I've been wearing most of this summer is just like a Bass Pro Shop hat that I got for $5. And yeah, it's disgusting, but it's a great hat. I mean,
That's right.
it's mesh, so it actually like lets your head breathe, and it's really pretty cool. Oh, oh, gotta look at that.
This used to
What?
be white.
Oh shit.
And
Wait. Hold on. I can't really see it. Let me pin you or whatever that's called.
pin? You gotta pin. I gotta just
Oh,
talk.
you're all okay. Say that really used to be white. Are you serious?
Oh yeah.
Yeah,
Oh
white and purple, man. K
my
State.
goodness, that is an excellent hat. So what is that? Circa 2003, 2001.
Probably. Well, I went to grad school in 2004.
So
So
04.
04, 05.
This is
Jeez.
absolutely ridiculous because I know there are more athletes than just athletes that play football, and there have been more football players at K State than one single player, for over a series of 4 years. But whenever I hear K State, the only name that ever comes to mind is Darren Sproles.
Darren
Oh well,
Sproles.
you're
Yeah,
too young. You don't remember Roberson.
I do
I don't
not.
remember that either.
Oh,
I loved watching Sproles because he's
they could
so
have
damn quick.
beat if they would have won. They could have won a national championship with him, but they
Who
lost.
was the big popular coach at K State?
Snyder.
Schneider.
Yep.
Thank you.
I
Yep. Yep.
remember
Bill.
we went to a local medical clinic, and we were just sitting in the waiting room, and I was watching but not really paying attention. And a guy walks up to the counter, and the lady says, she's looking down at her stuff, says, "Hi, how can I help you?" And he says, "I got an appointment." She goes, "Okay, well, what's your name?" And he goes,
Schneider.
"Bill Snyder." And she goes, "Oh,
Bill
I'm
Snyder.
sorry." Like,
Oh, jeez.
he's like, "It's fine."
Bill,
You know?
how you doing, Bill?
So,
Well, honestly, I mean, there are some people who don't, like I live in Kearney and I don't know anything about UNK's football team. And
I don't either.
if I lived in Lincoln, I wouldn't know anything about the Lincoln football team. And so it would be a situation where there would be quite a few people that are like, I don't know who you are and I don't know what's going on, but
yeah.
whatever. It's sort of like what is it? Devaney, Bob Devaney?
Yeah.
Wasn't he a football coach?
Yep.
Like a
Few
really,
that
really
was a
good.
few. That was a handful of coaches ago.
And then there was what's his face, the really really popular one. He's
Tom Osborne.
Tom Osborne. There we go. Because Bill
Adam,
Snyder,
not
Tom
knowing
Osborne,
anything. You just get
yeah.
out. You can leave.
Because Bill Snyder, Tom Osborne were like at the same time, right?
Yeah, for quite a while.
Yeah.
Yep.
for quite some time because they were all in the Big 12 at that point.
Bob
Well, Big
Stoops,
Eight
and
Big
yeah, I was
Yeah,
gonna say it
right.
started as the Big Eight, and then and of course the Big Ten, which now has 18 teams in it, but it's still the
Yeah.
Big Ten.
Oh, it
The move
never
to the
made
Big
sense
Ten was
before.
weird.
Like it hasn't
I
had
know.
10 teams. Anyway,
Doesn't make any sense. I liked the Big 12 because I mean it's like Kansas gets to play Nebraska and Kansas gets to play Oklahoma and Kansas gets
yeah.
to play Texas. And
Well,
it
they
just
wanted to
makes a lot of
chase the
sense.
money and the competition because the Big 12 was kind of going downhill.
I remember they went to the Big Ten and they were like, well, the main reason is so that we can compete in research with the R1 universities in the Big Ten conference. And I remember hearing that and being like,
There's zero
Baloney.
chance that
Carp.
well, they might have
Baloney.
convinced some money
I call
people that
carp.
that was the yeah.
I call carp.
I call
That's
carp.
some stinky carp is what
That's some
that
grade
is.
A tilapia right
I
there.
was like,
Fish
yeah,
bottom
it's a
carp.
university trying to justify university-ish things, but in reality, they just want to play Ohio. Like that's it, you know. They want to lose every year to Ohio. That's fine. It's cool. Or Ohio State or whichever
Ohio
one is
State, yeah.
the horseshoe.
Ohio
Yeah.
State. Oh, Ohio State, Wisconsin's typically up there, and
Yeah, Wisconsin, Minnesota.
yeah, they are.
Yeah, they're usually pretty darn good. And then there's Penn State. You know, they're just amazing. Everybody loves them. The fun thing about Penn State is the only time my last name was in the news was when Graham Spanier was the president at Penn State when all the bad stuff broke with his coach or whatever. I was like,
Yeah.
oh, great. That's wonderful. You know, at least the only time people hear Spanier, they're like, oh, it's not the guy, you know, did bad
Quiet.
things. Quiet, Adam. Quiet. My last name is no longer Spanier. It's Spaniard.
It's Spanier.
It's Spanier. Make it French. Gotta add a little bit
No.
of extra phlegm. Spanier. Or super French would have been Spanier. You just don't say the half of the word is all you do, you know. All right. Anyway, there we go. Good conversation.
We should figure out. I thought maybe we should just talk about tech news, like
Oh, tech news. There we go.
something we know about.
Yeah.
I don't know if you guys got any.
Well, I'm gonna go browse around. I haven't looked at it today.
Yeah,
See.
well,
Oh,
My
Intel.
my tech news is it's 3 weeks till dove season. That's my
What
that's
what do you guys think about Intel? And all their downsizing and blah blah blah.
So do you have a 13th or a 14th gen Intel CPU?
No.
We could talk about CPU structure. Do you know
What
what
is-
they did?
What did they do? I don't actually know what they did
So
on that.
I don't know all the specifics. I've only skimmed some of the articles and the papers on it. But effectively, there's some over voltage issues to some of the parts of the CPU, and this has been known since I think they're starting the 15th gen or something like that. So 13th and the 14th gen both have this issue that over time they will overvolt some of the cores and they will slowly die, and you won't know anything about it. It's just your computer's getting slower and slower over time.
It's slowly getting cooked.
Yeah.
So were they like trying to do some subtle overclocking, or was it intentional? We're gonna break your.
I don't know. I need to do some more reading. I
'Cause
know
it-
that this is a known issue and they still haven't fixed it. So
It could be kind of like three things. It could be, oh, we were trying to overclock to increase performance, which reduces, shelf life, which I don't think that's it. Number two, it could be malicious, like we're trying to reduce shelf life of your chip. So
I
that you
don't
have
think
to
it was
buy
malicious because it.
So I think
I think it's just a mistake.
number three is they messed up. Like
Mhm.
they had the wrong voltages going into those logic circuits, and we're just cooking them over and over and over.
Well, it's just
iterating
it's not
parts.
consistent. It's just sometimes it allows the voltage to go higher than it should.
Mhm.
And
Now, where were these chips made? Are these Taiwanese kind of chips, or are they made?
I don't know where Intel has.
Was it yeah, it's just bizarre because in the production of chips, it's such a insanely sensitive process that you could just have one machine that is slightly off in the way that the tolerance, and boom, you have all kinds of different problems.
I mean, you went to school in the 90s and the 2000s. You know what an overhead projector is? That's all they're doing.
Yeah. It's just an overhead projector. That's it. They put the overhead projector up. They pop out the vis-a-vis pen, right?
I mean, technically speaking,
And they
that
draw
is what they're
circuits.
doing. It's they're projecting an image.
They're just projecting it. It's called lithography. Okay.
Yeah.
Yeah, so it sounds like it's a microcode fault, and they
Oh,
can
it's a
push
microcode.
microcode fix.
Uh-huh.
So it, your your one CPU instruction, right? So when it goes through the pipeline, right, that gets split out into micro instructions, which then get reordered and rejiggered, run through the right logic units that they have, right, that they can process it through. So those microcodes they can at least update. But as Chris said, once that thing is fried, it's fried.
It's done. Yeah.
It's done.
So basically,
And
you
the
start
CPU is
losing
still going to
cores,
work.
right,
It
or
just has
micro-
less and less capacity.
Yeah.
So if you fry those micro units, right, which I didn't realize for forever, right, they've been running microcode. Like,
Right. Yeah.
I it was something that's like, well, the lowest level you can program is assembly, and it's like, oh, unless you're Intel,
And then you go down to microcode, right?
or AMD.
I'm not
You-
even familiar with what microcode
at
is.
some point
so
you
you don't
have
know-
to go
so-
atomic, you know.
So microcode, right, is if you know, do you remember when I think I talked about it in class, like there's this fetch, decode, execute, store.
Yeah, every clock tick, and you got to do the snapping fingers
Well, but-
for every clock tick.
But see, when you say add in assembly, the microcode
That's
is
multiple
the things
things.
that go and say, okay,
Yes.
you said add, and the first one is a memory address, so now you need to go pull that in, right?
You got to
So
deref it,
you
right?
fetch the instruction, you got to go fetch the data. So all of those sort of underlying pieces
Mhm.
all happen in microcode. So it's the
Okay.
and what it can do, right, is you can have one or like multiple instructions come in, and it says, okay, I'm going to go and do this thing over here on these like micro units, right? So I'm going to go be fetching, and well, this micro unit can do addition, and this one can do floating point, and this one can do this. And so it's what takes all of those sort of high level instruction that we think of as assembly and split it out into the little pieces that exist on those dies. So
Yeah.
they can reprogram it, right? So when you do a firmware update to whatever the device is, right? That's what that is, right? That's the updating of the microcode so that it does different things when you say add.
Mhm.
It's a PLC for opcodes. Got it.
There you go. Yeah.
Yeah.
Well,
and,
it's just
and the-
there are programs are like donkeys. They're are like onions. There's layers.
Oh, layers. Yeah.
they're like donkeys. Yeah, you're thinking about
Donkeys,
Shrek.
I-
No,
wait,
computer
reverse that.
operations are like the Mandelbrot set. So at the closer you look, the more infinite the scope gets.
or
But I
it's-
thought we
it's
studied
turtles all the
discrete
way down.
mathematic, guys. You know, I thought it was discrete. I thought we went down to a thing eventually.
Yeah, there.
So you're
is.
telling me that microcode is continuous? Ooh.
Well, you
Well,
can
it's not
continuously
continuous,
count
it's-
individual things. I mean,
It's
Yeah.
it's got logic.
It's got logic in it because eventually it's got to get down to a stinking transistor of some sort, you know, at some
Yeah.
point. Somewhere along the way, you're going to have
There's
to have a voltage going
abstractions.
somewhere. Yeah. Yeah. And well, because what I've been wondering about Intel is like their stock is crashing really, 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 really bad, apparently, like 30% down or something. Which that's why I was wondering why in the world Intel is crashing, right? Like Intel has kind of dominated the market
Well,
for
I
the
think-
longest time.
But I think
Does this
think
have to do with the
people-
risk-sys conversations you and I've been having
Well,
for a
yeah.
while now?
yeah.
Yeah.
I think both things are coming into play. If you look at, I mean, first of all, I don't think Intel's going to die. Period.
Right.
Like they're just going to become a chip fab at some point.
Right.
And they'll probably continue to make computers for quite a while. But I think there's writing on the wall that says, okay, what is Windows? You know, if you look at
Mhm.
our favorite feature, you know, recall on Windows, right? Where is it going to start? They're going to start that on ARM.
Mhm.
And you look at how Intel has been thrashed as far as, you know, power consumption. Like you know, they've been thrashed on that, and then you sit there and look at a Mac M3, M4.
Mhm.
Like I think they're just, it's going to be
So
hard
do you think
to keep
do you think
going.
companies like Snapdragon are going to jump up and take market share, quite a bit of market share from Intel?
yeah.
Competitive ARM, you know, non-Apple.
Well, okay, you
or
think about
non-Mac.
it, like why is all the malware on Windows?
Mhm.
because it was widely used.
Because it is the dominant market share, right?
It's the dominant market share, right?
When you look at
Right.
business, like that's what business does. Lots of home people, right? Like I don't know if it's 60/40 or 80/20 Mac, Windows, Linux is something.
Us weirdo Linux people, yeah, we're
It's a
the
slice
0.01%,
sliver. But like you look at that and it's like, I have a hard time seeing that Intel's gonna keep going.
Is it going to
if
be?
they
It's going to
lose
be like
that.
IBM. IBM used to be like market dominant. They dominated literally everything.
Oh yeah,
and now
I think
IBM.
Intel's just gonna keep printing money. It's just they're gonna
Yeah,
fire a bunch of people.
yeah, yeah. I think they're going to keep printing. And I
They're
think
gonna
they're so
fire
long
their
in the
chip
tooth.
designers. They're not gonna fire their engineers who design circuits. Like they're gonna make
Right,
chips for somebody. Period.
right. Yeah, and I think it again. It's sort of like IBM. They're going to change their business model. Is what they're going to have to do. So yeah. So again, instead of designing the chips, they're going to make the chips. Have somebody else design the chips. They can make more money without having so many people, and they can specialize a little bit more. And if they get a pretty forward-thinking CEO, which I imagine their CEO is going to end up getting cooked after something like this, but they could try to do something to make move into the future a little bit better with especially the ARM, because ARM is coming and it's going to be the dominant
But see, the funny thing,
instruction
right?
set.
The only difference between, from what I understand, the only difference between ARM and x86 is the decode. Like
Yeah.
your decoder is the only, and that's in the microcode, right? And so
Yes.
that's why, Apple Silicon can sit there and run both, right? Because it
Mhm.
has that. And if you're just sitting on the same platform, all your system calls, like if they're ARM or if they're x86, it doesn't matter. Like how it
Right.
interoperates with the hardware is the same.
Yes. How does it convert into the microcode, right? Because if you're using the more efficient ARM sort of conversion, then of course you're not going to burn as much battery life because you're not doing so many different instructions through so many different transistors. You're
Well,
doing
it's just the decode, right? So if you think of
Yeah.
like the complexity of the decode on x86
right.
is
Because it breaks out so into the crazy amounts of microcode. Even though most of the other stuff in the compile, or like when it goes down that far, it's optimized, right? So again, it's going to be using the most efficient microcode bits, except the decode side of it, which is very complicated and eats a lot of energy and all that kind of stuff.
Yeah.
So, but I mean, and I remember, and I've talked to you about this, when I was asking about, what is the operating system of the future, and you basically just looked at me. This was back in 2018, looking at your shirt, and you were like, it's going to be reduced instruction, so it's probably going to be ARM. And here we are. It is ARM 100%, and it makes sense, right? Because we had to move into reduced instruction for like phones and tablets and stuff like that.
See,
And
I don't know that they're that much reduced, other than I think because they have the lower decode, right, and they weren't
Mhm.
hamstrung by what Intel was hamstrung with, right? They got to be able to decode, 32-bit, and at one point it was 16-bit, right? And like,
right.
I think that doesn't explain why it would be so much less efficient. Like decode, I don't think is that much of an overhead on it. But maybe I'm wrong, or maybe it's the other operating systems are able to sort of better leverage that
Right.
different instructions.
When I think a lot of it, I mean, the decode is, but also I think the fixed bit width of all the instructions is probably really important in the ARM. You're not dealing with variable bit instructions as well, which adds
When you get rid of
adds
thumb
complexity.
mode, then yeah.
Yeah, right.
Well, you really aren't with. I mean, how many 32-bit systems do you? Well, I guess in the business,
I mean,
you still
64.
find quite a few.
Yeah, but even
64
right?
standard, but there's still
Yeah.
32
Yeah, but
around.
nobody's running around on a 32-bit machine anymore.
No. Most, even x86, it's x86 64. They're not doing any x86 32s anymore. I mean,
Mhm.
I think the old Unix box you had running was an x86 32, wasn't it? Because I remember
I don't remember.
I think we were doing it all in 32-bit mode.
Well,
What was the Kraken running?
Well, that was
That was a different
Windows.
box.
That was
Yeah,
definitely
Well, it was
64-bit.
GPU based, but I didn't know what it was actually running.
it was. Was it Windows or was it Unix? I thought it was a Unix box.
Well,
'Cause
now
we
you're making-
SSH'd
I don't
in.
remember.
We SSH'd into
It's
it.
been a number of years now.
Yeah, it's been a few years. 2019, probably.
It's okay. I was thinking the other day, I'm like, it's been 4 years since I was a teacher.
Yeah. Time's gone by
That's a lot.
fast. It's ridiculous. And now the punk senior, upperclassmen like us are like, we're in grad school and so smart now.
No, the only thing you learn in grad school is how dumb you actually are.
Yeah, that's exactly right.
Well,
I
you
just feel
get that
dumber than I've ever
perspective
been
of
before.
like when you get done with your high school, college degree, you're like, look at how much I know, and then you start getting perspective, and you're like,
I know nothing.
I always talked about it like when you're in getting your PhD, you're learning more and more and more about a topic that's smaller and smaller until you're like
Mhm.
Hmm.
the expert on this tiny thing, and nobody cares about it.
Yeah,
Yeah.
nobody cares.
Well, I
Like,
mean, especially in these tech jobs, if
Right.
you go straight from undergrad to a job, depending on what you're doing, you're likely going to learn more in that first 3 to 6 months than you did for 4 years at
Oh yeah,
school,
I
just
learned
in that
more
narrower topic.
I learned more in 6 months working in a company about database than I did in a class that I took about database in
Mhm.
grad
Yeah.
school
Yeah,
because
'cause
I
you're
didn't
doing
take
it.
it in college. I didn't
Yeah,
have
it's all applied.
I didn't
Yeah,
have Sherry for database, so
we had Sherry. It was
We
great.
had Sherry.
Yeah, well, and ultimately working at a company, I mean, you're working there 8 hours a day, all day long, constantly.
Well, that's
And
true
with
too.
a
Yeah.
class, you're only having 55 minutes, and most students aren't motivated to work 8 hours a day
well,
to
and
learn
when you look at a
things, you know?
database, you're like, well, why do I care if it's in first normal form or not?
Right.
Like
Right.
you get
Yeah.
in the real world, it's like, well, I don't want to have duplicate data around. Okay.
Right.
Well, how do we design an intermediate table? How do you do one-to-one, one-to-many?
Right.
Like most of those
I don't want to have
things.
any duplications, right?
And then the
Well,
joins are just awful, and I hate doing
Right.
them. But
Yep.
right. Joins are miserable. Like, I just absolutely hate everything about joining, but you have to do
that's
it.
why I
mean,
don't do it. Like
Yeah.
honestly, why are you having the database? Like, is the database really more efficient at doing the join? And if you did it in programming
Mm-hmm.
for some applications,
Well, and again, anymore, it's databases are generally abstracted by some sort of framework, right? You're using Django,
yeah.
so
Yeah.
you don't ever have to deal with that. Like, it's not even something that you have to mess around
Well,
with.
mostly.
I was
Right.
gonna say there
Like,
are
for
times,
example,
yeah, with
right?
that knowledge.
So in Django, you can add like additional things, and
Mhm.
one of the things that we were sitting there doing something, and it's like, man, why is that query so slow? And then you
Mhm.
realize, oh, I don't have an index on it. It's doing a string
Right.
lookup, and there's no index on it. So then you have to go and you have to add an index. Once you do that, oh,
Then
wow,
it's so much faster.
Those lookups
Right.
are just like lightning fast now.
Right, and what I was getting at is like you got to understand the databases, but you're not going to work directly with them as much as you're going to in obviously a straight
Yeah,
SQL
most of
kind
the
of an
time
application.
we're not like a majority of the stuff that we do. Django has an admin interface where you can
Right.
edit,
Go through and
like
yep.
data values, and then Django defines what the model looks like.
Yep.
But I oftentimes sit there and run raw queries, right? Because it's easier for me
Yeah.
to run a raw query on the database through a Django's interface or Postgres's interface than it is to
Right.
write a script to do it.
Write a script,
Like,
right?
I'm just not gonna.
That's-
not gonna happen.
That was one of the nice things about Django as a framework, having that admin console, because it allows you to access and get into your data a little bit more intuitively. I mean, you can still run your SQL if you want to, but in operation, you're generally because once upon a time before you had frameworks like that, you had to really worry a lot about what information was getting into your database, right? Like if people are doing SQL injection or they're trying to mess
Yeah.
around. And a lot of that stuff is now taken care of and abstracted away. But the issue then is, in all frameworks, abstraction leads to complexity, and then it can be really difficult to even know what in the world you're
Well,
doing, right?
it's like a lot of times, right? Teaching students about the fact that, like, okay, if you abstract something, you still should know how it works because
Yep.
otherwise you're going to have, for example, performance issues because you don't understand
Mhm.
how it works. And you're just sitting there saying, well, why doesn't it work? Why isn't it fast? Like that index, right?
Right.
Well, why isn't
Mhm.
it fast? Or I'll give you my latest performance one. So we draw nodes, right? People, and then they're connected like spouses and children. And like when we draw it with, 50, 100 people, it's fine. But somebody asked us, can you draw 800? And I go and I try and load one with 800 and it's like, ka-chunk, right? Like, and so I start going through the code base and I'm like, oh, we got so many places where like you do a for loop over the whole list of nodes and then you do another for loop over the whole list of
Mhm.
nodes. And like when it's 10 times 10 is 100. Okay, great.
That's a lot. Yeah,
But when it's 800
800, yeah,
times 800, and really it's actually even more than that, because if I have that many nodes, like there's actually a connector node and a lower node, and there's lines and all of those things. So like now my couple goes from 2 to like 6.
Let's
So now
let's
it's
give a big O
6
notation on
times-
that now. Let's be proper. What's the
it gets exponentially bigger is basically what you're saying.
Well, and
It
some
doesn't.
of them,
It's not linear.
some of them it's the problem of like it really isn't that slow, but when you're dragging a node on the screen and it's doing that every single update.
Mhm.
So Chrome, it has to, and you're going to get a warning in Chrome if it's over
yeah, memory.
40 milliseconds, I think, or something like
Mhm.
that. I don't know what the real number is, but you'll get it. It'll be like, oh, this is the long running task, right? So like,
Yeah.
and then all of a
But
sudden,
Firefox does that too.
yeah,
They're
your
like, you wanna
frames per
stop it?
second just
Yeah.
drops, right?
Yep.
You're like,
Yep.
well, why is it dropping? Well, that's because, yeah, this really isn't that big, but when you're
Mhm.
doing it every reframe, so
So
one of
so
the-
in order to alleviate that, was that a read into memory problem, or was that a changing your access and searching problem?
well, it's partially having to do with the framework. So
Mhm.
React has this sort of this notion that like you're a thing on the screen that is a child of something else, right? Like you sort of push the data down into your sort of children. But that's
Did
sort of
you did that?
He gave himself a
I
thumbs
literally
up.
I can't do it.
Oh, I thought it was Adam that did. Okay.
I
No,
literally
didn't.
can't do it to save my life when I
Oh.
try, but when I'm hand motioning, all of a sudden, like things come
I
up.
think
I
it's
don't know.
it's
It's
his
on my
Mac
Mac.
that does
It's-
it. Yeah.
Anyway,
Yeah, I'm
like
a
so
Linux
React
loser,
has this
so-
this notion of like, so if you have a component that like updates the state, it's going to re-render all of those things that update the state. Well,
Mhm.
when you sit there and make one change to one node in a list of 3,000, you then have to update the state for all 3,000 nodes,
It has
because
to
that
pro-
node is
yeah.
basically pushing up to the top, which is that, then pushing
then
down. And
Coming
even
back
though
down.
these haven't changed, it re-renders them because it thinks they might have changed.
Mhm.
And so what we have to do is we're going to have to not push updates. So push it into a shared state. So you push it from the component level. Like we were keeping track. How many times were you clicked? Well, again, that makes
Mhm.
sense when you have one, but when you have 800, it's like, well, do I need to update the whole list when only one has changed? And I literally want to change one variable. I mean, it feels like when the functional days, like, oh, you've updated one bit in the state. Let's
Do
rebuild your
everything
ent-
again.
your
Yes.
entire function.
Yeah, because we don't save anything, so we're just gonna regenerate literally everything from
Oh
the
my
ground up.
Like
Yeah.
functional programming will always fail.
Ugh,
But
it's nichey and it's neat, but it's so inefficient. It's just ridiculously inefficient. I mean, it's
Yeah.
good for what it's good for, but compiling, and that's about it. But
yeah, I mean, the people who love it, and they
Yep.
want to talk about type safety, but like,
yeah,
if normal people can't use it and you can't do the basic things that like most dumb apps need to do, like why are we?
when ultimately, like in computation, computability and complexity are big. Like they're really, really big deals. And if you're running on some sort of a paradigm for a language that's bad on both of those accounts, then I don't know what the purpose of it is. Like it's neat, it's fun. For us as computer scientists, it's interesting to mess around with, right? But in terms of application, it's a little bit funky.
Well,
you
all the functional bros think that we're just idiots because we don't like programming and functional. So
Right.
I was gonna say, like that argument is literally inverse for some of the people that I know.
That are
You
functional
use
people.
object oriented. What a joke.
well, I think so. I think both fields are right.
Yeah.
Right? Like,
Yeah.
I watch the Primagen, which is on YouTube, and I agree with him on a lot of takes, and some of them are like, object oriented is fine if you're like one level, maybe two. Like you can
Mhm.
have an object and maybe an aggregate that has those objects. But when you start talking lots of levels and inheritance, all of a sudden you've got so many dependencies
It's a
that
mess.
it actually it makes like it's great in theory on a whiteboard, but when you get to practice, like, does it really help you?
Mm-hmm.
There are lots of times in CRUD applications where it doesn't, and you end up with problems. There are times, like for example, our drawing thing, right? We use a centralized thing called an ID, right? That is like an object that has a location that has an ID, and things inherit from that, and that makes sense, right? Because they are always
one level.
Yeah, they're always going to be at that level. But when you start like adding, this is a this type and a this type and a this type,
well,
right, you run into
ultimately,
problems.
You were just talking about React having this really big parent-child, 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 parent-child chain, right? Which is essentially object-oriented, right? So you have this is a 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 this, right? And now jumping from here to 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 just get to anything is ridiculous, right? Especially if I could just reference the memory location of the thing immediately instead of having to go to this location or this address, that address, this address, that address, and just jumping all over the place just to get a number.
The big thing that I think people are realizing is that I think React as a framework was a good idea 10 years ago because of the sort of speed issues of the DOM and browsers. And the notion that I'm seeing a lot is that maybe it doesn't make sense in 2020X. Right. And there's this giant push to like, HTMX, which is a new framework that's like super minimal, that people are thinking, well, there's all this momentum of React, right? Like if you want to go make a component, like you want to assemble software out of React, there are so many pieces you can pull from. But I think we're going to end up with a backlash against that because of the performance. Just like I was talking, the performance hit of that. Like in mine was just, you got one level and then it has all these things on the screen, and any one of them can make an update, which then sort of forces that repush, which is terrible.
So then if you have a pretty big tree, right, and something way down here has an update, it updates up, which updates down, and has to like proliferate
and
across
that's the thing that React is going to always be terrible at is, and it's made for like, okay, I have a thing and then I have a smaller thing and then I have a smaller thing. And if I go up, then I don't necessarily have to do like the number of things in that list is supposed to be small.
Right.
But that's not how lots of applications, some applications don't fit in that mold, and then you got trouble.
Yeah.
You always got to remember, I mean, at the heart of that, object oriented versus functional versus whatever debate is it's literally what brand and type of tool you want to use to make machine code understandable to us dumb humans. So why not keep a toolbox of multiple things so you can respond to anything versus perfectly standard.
Look at Java, right? Like I remember Java 1.2, which was way back, through like 1.5, which then they rebranded 5, or then they redid them after 4. They did like a 1 series and then they changed it to 4, 5, 6. Anyway, like they've added a ton of functional, features like the consumer, the arrow operators. I don't know, you guys use those, right? So like,
oh yeah, John had us do some stuff with those.
Yeah. What are those called? Oh shoot,
it's like this. It's like the C kind of a notation, right?
They're not. We used them when we were doing some Lambda. Stuff.
Yeah, it's Lambdas, right? So anonymous functions. Which FYI,
anonymous
the like
functions.
handling of errors in an anonymous function sucks, right? Because it doesn't tell you the stinking line number, or it didn't at least.
Yeah.
But like you see the languages adding these different features, and I think that's a benefit for us. Like, but Chris, you were saying it's a tool. I think of this happens in any field. I think of woodworking because I do that.
See,
yes, exactly you have a set of tools that
you've got the people that are like, I use all hand tools, and you got the people that are like, I use all power tools, and you got me. I'm like, I use tools.
I use whatever is good. Yeah,
I have a hand planer. What you have at hand and what you're capable of using.
Well, and ultimately, what's funny is people who get caught up on the code. Like, I use Python, I use Java. It's like, well, I use DeWalt and I use Mackie. Like, what do you like? What do you
No,
want to
but Adam, I think
get
we can
at?
all agree. Like, did you guys see the CrowdStrike breakdown of what that bug was?
Yes.
Hmm.
Regular expressions.
Yep.
Oh no, I didn't go that deep into it.
Yeah.
What?
Oh my goodness. Oh, this is. I mean, so like they had a function that took 22
Oh god,
parameters,
that makes my heart hurt.
and they forgot to add the 23rd. I think that's the number. It's 20 something.
Oh,
First of all, they got a function that takes 20 something parameters. Okay, that might be an issue. You know, when you get
good
past
grief.
19.
So how does that break the operating system then though? Is
Well,
just,
it
just
Well, they're
assumed
trying to pass.
it assumed that there were 23 arguments, but only 22 got passed.
Would
And
be
so the
passed.
last one was empty or
Is
null.
null. Yeah.
And then it added an offset to it, and then it caused it to
Oh,
crash.
so you're just reading garbage data. Okay.
Yeah, it's just going outside and
Garbage
reading
data,
junk.
yeah.
Yeah. Ugh. Could you
So
imagine?
I think we can all agree that like almost always, like I tell my employees, like do not use regular expressions. Like they are terrible. Please do not
Don't.
use them.
Don't
You
even.
know, it's a
touch 'em.
great logical experiment, and like if you want to use regular expressions to search for something, but not like an actual running piece of code, that's what they're for.
As
That's
I've heard that called write once, read never.
right.
Because you can read it as you're writing it, but when you go back, you're like, what is
I
it?
have no idea. Right. Well,
Like
and
if
I
you're
was
like Chris, I think you're right. Like if you have a dot star, okay, or
understandable.
maybe a dot star and then something else, okay. But when it gets into parentheses that you cannot like
Mhm.
just quickly look at and understand, like okay, we're too far.
Yep.
I was working on a research project, and it's sort of this language agnostic static vulnerability analysis stuff. And the person that was working on it before me was a previous student, and he was parsing out a bunch of LLVM using nothing but regular expressions. Like every single instruction was a regular expression. And I got into the code, and it was like, oh my gosh, like it's
But it was
very
fine when I
complicated.
started. I only had 2 of them.
Yes. Well, and it was hard because I mean, he did it out of necessity, and I totally understand where it came from. But as it continued on, and as a new instruction is encountered, you have to create another regular expression. And after 6 months and a year goes by, and you have hundreds of regular expressions, you have no idea which regular expression is being used in a given case. And so now you're developing bugs. You have no idea where it's going and why it's doing it, and you're trying to break down your regular
The
expressions
bugs
to understand.
just go.
Yeah.
And so when
Every
I jumped
added
into it,
instruction, exponential increase.
Well, I
It
was going to
just-
say, yeah, your bugs become the main population.
so
They've
so
taken
I
over.
Colony.
yeah, I took it into the parse tree. I was like, forget about the regular expressions. I'm just going to parse it out and call it a day instead of matching each instruction, which can potentially have a bunch of different formulations, right? Depending on the different combinations of arguments that are passed into that thing. And so, yeah, it was a big mess. And regular expressions, anytime I even hear it, it's like, I just get an immediate headache from it because, again, like a dot star is fine. I mean, that stuff is a piece of cake. I mean, even a little bit more complicated than that, like I'm looking for alphanumerics or something like that. Whatever, that's cool. But anything where you have a bunch of characters,
for example, emails, notoriously terrible to parse.
yep,
like-
terrible.
You can literally have comments in an email address.
Mm-hmm.
What the?
Bizarre. Well, and that was like in one of the classes that I took, one of the things we had to do was validate an email address. And initially I was like, oh, that's not a big deal. But the instructor was like, you know,
If you
And it
Google
was-
the email address regex, I mean, it is amazing. Like there is literally one, and it is.
where was that at? Which site are you looking at? Is it a
I think the Stack Overflow one is wrong.
surprise? What? Stack Overflow is wrong. Who would have
there-
thought? Oh, good grief. There's a reply.
Yeah, it is, and it is
Ew.
literally unreadable. like 100%.
Well, they even have the finite state machine representation of it for the regular expression. Do you see that?
Oh yeah, I mean
Good
it's
grief.
terrible.
Oh my gosh.
Which is why you should like you can write a parser, and there are good parsers out there that. I was trying to remember which one I used in Python.
We used Yak, I believe.
Yeah,
is what we were
there's
using.
Yak.
There's
and
also
Bison,
Lex. Lex.
Lex.
Is Lex?
But there's
There
is
was
it PG?
there was something else that we used.
That is the neatest application of a finite state machine I've seen, though.
It looks good, doesn't it?
Yeah.
It looks really, really good.
I mean, the string of characters in the rejects, no, not at all. That's
No, but good grief.
that's character salad and not good character salad.
Oh my gosh. Like, I'm just gonna
It's shorter than I expected, which I mean, it's fairly long, but it's shorter than I expected.
we're gonna do because it's oh geez. I highlighted way too much.
Yeah, I think the one that I ended up going with was a PEG, parsing expression grammar. I'd have to look in my code base to see which one it was. Anyway, there are some simplified ones where you sort of eliminate ambiguity, right? So then you don't have the parse tree problem that you have with a standard parser, and you can actually make a much simpler parser if you get rid of the ability for there to be ambiguity. But I can't remember. I used a Python library, and I have my code here. No, that's not the right
Yeah,
code.
basically everything is saying like there's other ways to go about this than a regular expression. You really shouldn't.
Well,
But
also,
if you
most
must,
people-
here you go.
Most people
If you
like
gotta.
if you want to get the 99%, right? Most people have a certain set of characters for the username
Mm-hmm.
that they will
Yes.
use. Most people don't accept plus anymore, so like that was a nice one when Google did that. But yeah, you can do some basic things like, okay, I got a bunch of alphanumeric characters plus a few special characters that most people might use in an email at domain that is again characters with some dots.
Yeah.
Call it a day. Like
yeah. Well, and ultimately, like that's even more of a cybersecurity. Like a computer scientist is thinking, how can we get all the combinations, and how can we do it efficiently?
Well, I think most people who do regular expressions aren't thinking, but
a cybersecurity guy is like, how can we minimize this as much as we possibly can? Because, I mean, even efficiency. Like, if you're thinking about computability, like, why would you make a complicated regular expression with too many different nuances in it, right? You want to keep it simple.
Well, let's see. I
Keeping
think
it
that's
simple is good.
People don't understand that like regular expressions are just terrible to maintain.
Yes, awful.
Absolutely
awful.
Unless you have some sort of visualization, right, that lets you understand how that is. Like, they're basically they are state machines, right? And
they're state machines. You're literally working with a state machine, and they get out of hand because
if
you
you don't
keep
draw
adding
on
and
the
adding
sidewalk using chalk,
Right.
you're not going to understand how it works.
Yeah, you better have like a big conference room with a big whiteboard, and you better be updating the drawing on the whiteboard every single day, every time someone changes that stinking regular expression.
Well, but also like you can't update that. Whatever data you're using that regular expression to accept, once that regular expression is developed, you're locked in, because you're not just gonna slightly modify it for a whole new set of things that you want to allow. Like,
yeah, I mean,
no,
come
not gonna
on,
work that
Chris.
way.
Sure, we will. Might as well just change it as we're going.
That's like back in object-oriented programming, finding out that one of your labs you messed up somewhere halfway through. So instead of trying to fix the problem, you just wipe the code and start fresh.
Start from scratch.
Sometimes that is the best solution.
It is,
A lot of
but
times it's
when
the
you
best
have a
solution.
1,000,000-line code base, like maybe not.
So
Well,
so
like you
in
were saying,
artificial,
Adam, right? That code base that had all of those regular expressions in it, like that, that just would be. You probably would be better off starting with.
which I did. I started from scratch.
There you go.
I started over because I was gonna go parse. I was using a parser anyway, so it's like, of course, I'm just gonna go to. I'm gonna use context-free grammars, and I'm not going to use regular expressions, and it worked so much better. And
Was it the kind of situation where, like, going back to the tool argument, someone found a neat tool that they found really neat and really fun, like regular expressions, and decided I have to shoehorn when another tool would have worked just as good, I have to shoehorn this tool into doing what I want because I find it neat and cool right now. Was it that type of situation, or?
I think the use of regular expressions is more lazy. I mean, to me, it's like if I'm trying to actually like detect or determine some sort of a string of some sort, and I have some knowledge of computer science, and I can think, oh, I can use a state machine to parse this, then a regular expression obviously is going to be like, oh, this is like the fast and dirty way to solve this problem. There's
You
really
don't
no
just do like a
nuance to
1,000-line long switch statement, like,
Yeah,
okay, well, it
well,
could be this. No, it could be this. No,
it
it
could
could be
be
that.
anything, right? Yeah, right. And and so and it is one of those things like and I don't know whether it's that a lot of people just don't understand regular expressions or how they fit with grammars or all the different automata theory that we go through as computer scientists and the tools that those things offer that can actually solve the problem better.
Oh, you
But
mean
I
we
know
actually use that stuff after school?
weird, yeah. What's interesting to me is, I've done it before. I've reached for the regular expression because it's a quick, dirty, easy to understand initially, easy to understand solution for a problem, right? If I'm going to try to validate, especially cybersecurity, right? Trying to validate some input or something, right? A regular expression is really easy. And HTML and, it offers some regular expression functionality. Or, I mean, if you're writing in Java or Python, whatever, you've got your regular expressions there that can do what they need to do. And so it's fast, dirty, basic, simple. But the problem is as it continues, the complexity goes off the charts. And essentially, you're just playing a game of combinatorics, right? So now the more complicated
Well,
your
also they're super terrible as far as if you have a bunch of regular expressions, right? That runtime is awful.
It's
Like
horrible.
you're so much
Absolutely
better
awful.
building a state machine. But
Right.
I think regular expressions are 100% fine if you're on the command line, you know how to use them in grep or sed or whatever tool it is. That's fine. But if you're going to build a system,
inline code, right?
That like
well, that was the
has
point that
code.
I was trying to make. Like, yeah, if you want to search for something,
Yep.
That's why at runtime, once you're that's
I
fine.
taught students like, okay, you're on the command line, you're going to take this class called Automata, and you're like, it's stupid. I hate it. And I'm like,
it makes no sense.
The one
Why
place
am I doing
you will
it?
ever use this is on the command line, going through logs, files, whatever it is. You need to understand what that dot star dot plus whatever mean. Yeah. And if you
I wouldn't code.
No.
But yeah.
Don't ever write that in code. It's just ridiculous. And that's, I mean, and the inefficiency of it, right? Like Matt was saying, I mean, as computer scientists, one thing that we should always be concerning ourselves, and I tell students this all the time, think about the efficiency of your program. Don't just take it for granted that it's going to go fast, because even the best computer scientists like Matt, who have tons of experience and are thinking about it, run into it, right? So if you're thinking about it and you still run into it, how bad does it get when you're not thinking about it, right? When you're not paying attention to those things and you're just reaching for regular expressions that end up being hideously complicated. And now you're just doing rough combinatorics on the entire string to make sure that it works, right? And it's just, it's so slow and it's so inefficient and it's impossible
you'll run
to maintain.
into it on those functional examples too, right? Because people will sit there and say, okay, well, I can use a lambda, and one lambda is fine, but if you have 5,
nested.
10, 100, well, not
Or
even
1,000.
nested, right? Incremental. Like, okay, now if your set isn't getting smaller, you're going to n, right? You now have just made it 5 times slower because you didn't put them in one function that does, one iteration to
one
rule
thing
them all as opposed to 20.
Yeah, well, and ultimately lambdas are one of those things that I think a lot of computer scientists learn lambdas and they're like, I'm cool now, right? Because it makes
it's a hipster. It's a hipster black box.
Super, I did some job interviews and every single one of them was like, do you understand lambdas? Do you know how to write anonymous functions? And it's like, yeah, it's just like writing another function, just a different notation. But it was like this important key element in surviving in the industry, right? And to me, my opinion of lambdas is a lot like Matt's opinion of lambdas. Like, okay, cool, I can write this function right now.
I was just going to say, you could just write the function without the lambda. I could make a function that does the same thing the lambda does.
I could write it right now in this line, okay? Or I could just make the function. Now
Yeah.
again, if you're talking about the jump statement, if we're going down to like, oh well, now you have an instruction that's going to make it jump, and you got intra procedures and extra procedures, blah 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 blah. I mean, maybe you could talk
Well,
about
there
that in
is
terms of
benefit
efficiency.
if you're filtering a thing down, right?
Right.
So you don't have to build an intermediate list maybe to get
Right.
intermediate results, right? So
You
there
could just
are
walk down
going
it.
to be performance gains if you can string together functions and your input size is winnowing down and
As
you're
you
not
go.
doing it a ton.
But
Yeah, the situation.
well,
where
because
it's-
ultimately at that point it's a lot more like recursion though. Like if you're increasing your data size as you're going down, it's just
That's a
getting
wait,
really out of hand, right?
is there any situation where that actually happens?
or
I
what
don't know.
happens.
Because I mean, you're technically filtering it, so you're either gonna have the same size as
Well,
the initial call, or you're gonna
It de-
reduce.
it depends on what the lambda is doing.
That's
Because
fair.
I mean, a lambda function is a lambda function. You can make a
It
function that
could,
does
yeah, it could do anything.
I
Yeah,
mean,
you're right.
you can do all
But
kinds
see,
of stuff
with
to it,
with
right?
the with like Java, right? The streams and those pipes, right? So you can start with your initial list and then you say, okay, if it matches this, I'm going to do this additional thing to
Stream
it.
it, yeah.
And so those streams will reduce the size. I don't know that recursion necessarily
Fits
other
in that
than
way,
other than curried functions.
right?
I don't think it probably wouldn't reduce it. Recursion's mostly for human readability as opposed to
Yeah, functionality
like it's
or
I
efficiency.
don't think
Definitely not
it's
efficiency.
never faster because
No,
instead
it's
of
never
doing
faster.
a loop, you're doing
You're shoving it on the stack.
yeah unless yeah. Like I said,
Yeah,
I think
well,
the
there's
intermediate
I think,
is a problem.
and again,
but-
this is probably a statement that is unproven, and so I'll say it that up front. But I don't think there's really any recursive solution that's more efficient than a procedural solution. Like I just don't think it's not a thing. And
but it is more manageable by humans, and human time
in the
is
code.
in general more expensive.
Mhm.
Right.
If it runs in the time, your human time is going to
So,
be your big cost.
Going back to the lambdas, if I'm going to be a raging optimist about lambdas, why lambdas? Like, what is
why
the
do we have
benefit of a
them?
lambda? Yeah, what's the benefit? I can write it here and I can write it now. Is that like is that
you don't have
it?
to stand up all the crud related to, say, an object
function.
or a function.
Right.
So, like, if you have a function that just does a thing, and for example, it's not operating maybe over a loop, right? Maybe it's operating
Right.
on a thing, and it does filter, right? So, a filter is a great example. Like, if you don't want to have the overhead of writing a function and having that code be a whole thing,
Right.
then the lambda does give you some benefits.
You're just putting the function code in the actual.
Yeah, it's inline
Thing.
basically.
Yeah, it's in line. But ultimately, functions, and again, I'm just thinking this through. Functions generally serve for reusability of code, right?
That's why I was just gonna say, like, you could just as simply then remove the lambda and
And just
write
code it.
manually the code of what the lambda's doing.
Yeah, you can. I think so. I think when you look at a language like JavaScript, then
Mhm.
because you have to do because it is functional, it
You
just
have
gets
to create
be,
a
there's
function.
a lot of cruft that you
Right.
can negate if you have anonymous functions. Like, okay, I need to add a handler for this. Do I really need to give it a name? Probably not. Like, I don't
Right.
need to give that function necessarily a name for it to be useful to me. So I
So in
think for-
JavaScript, there's a case, but what about Java? Like,
well, Java does
Python.
it because that they need to add features, right, to make people
Right.
love it.
like, I'm
People
thinking,
do love
I'm
it,
not
and
thinking.
people do use it. It's
Right.
nobody. If nobody used Java, nobody would talk about. There'd be no haters, right? Because they would be like,
Right.
well, it doesn't matter.
That's true. Yeah.
So
Yeah, it
it's
doesn't
like
matter, right.
Microsoft. Everybody uses it.
Right. And
Nobody
that's why everybody
loves
hates
it.
Or that's why you have so many haters, right?
Exactly.
Right. It's like Racket, everybody hates it. But with Java, only some people hate it, right? But the the use pool is
Well, and
tiny.
Mac.
Actually, I gotta be
Reasonable
honest.
people hate Mac.
I think John loves Racket. So I'm gonna be honest.
I'm sorry, I
there's-
gotta keep throwing that one in there.
Reasonable people
Pay no
reasonable
attention to
people
the
hate-
iPad that's sitting on my bed
No.
beside me.
reasonable people hate both Mac and Windows. So, I'm just gonna be honest there. So
And Linux.
I was gonna say, go ahead.
come on,
Linux
Linux, why
Master
did you
Race.
not dominate
Wait, hold
the
on. I
desktop?
gotta go
Why?
get my boxing gloves on.
Why? When is the year of the Linux desktop? Oh wait, it's on the Mac.
no.
Never mind.
Oh,
That's BSD. Sorry, my bad.
Yeah. Oh, ouch. Black eye right there.
Black hat.
Yeah, and that's so basically like in JavaScript, a lambda is going to make a lot more sense because everything has to be functional, and I don't want to stand up a function for that thing. I just want to use it, right?
Yep.
Okay, that makes sense to me. That makes sense. Of course, I'm not.
I mean, JavaScript
I'm not
is a terrible language. Again, everybody has to use it, and so you
I don't like
complain
JavaScript.
about
I hate JavaScript. I wish I'd never have to touch it. Everyone complains about it, right? But like, you have to use it because it's unavoidable. Because everything is sort of,
debugging it is. I hate it. I hate debugging in the browser. It's so bad.
Yeah. Well, and even just writing code in the browser, like that's. I mean, it's just ridiculous. I mean, because you got an IDE, you can sort of do that, but at the end of the day, I mean, you got to run it in a browser and make sure it works, and that's the debugging side
one
of it.
reason
and
I like doing backend work.
Right, and that's me too. Like, because all front end nowadays is JavaScript, some sort of JS of some sort, and that's why I love the back end because you can use back end, you can use Java or whatever you want to use on the back end, and it's way easier. Or Python, I mean, you use Python. I like Python, but yeah, I just don't like JavaScript, and I think the reason why I don't like JavaScript is I started on the back endy kind of stuff. My first language is Java.
Well, I think everybody who has types goes to JavaScript and goes, "Oh, this sucks."
This sucks. Yep. var.
I don't like I don't like the front end stuff. Partially, it's just because of the way
Because
that
of
I do.
JavaScript.
Well, but just the way that I do front end programming, which is we're gonna put this widget here. Does that look good? No. Let's move it a couple pixels over here.
Yeah.
Does that look good? No. There's probably better ways to go about it than that, but that's how I do it. So that's why I hate it.
Fonts and kerning and what does it look
Yeah.
like? And
Colors and
is
fonts.
it centered? Like those are whole things. And
I hate front end.
some of
I
us
just hate
hate
front end.
that, right?
You know how I do front end, Chris?
You hire somebody.
I was gonna say you hire a grad student.
I don't. I don't do front
I don't
end.
front end.
Because like
Everything I do is on the terminal and it uses command line options.
yeah, like who
Actually,
needs-
that screams Adam.
Well, but ultimately, what's funny is like I'm teaching the students Java FX, right? And Java FX uses CSS.
Are you doing computer graphics? Oh no, never mind. That's
No,
an
in object oriented. And so it's funny because it's like, again, CSS is hideously flexible. You could do such cool stuff with it. You can make it look beautiful.
Don't like it, but yes.
Yeah, but what a laborious, miserable experience to get it set up so that it's right. Like
Wasn't
in Java
Java
FX,
FX deprecated though?
no,
I think
there's no, it's not really deprecated. You can still use it. It's fine. The reason why I use it is just to expose students to a bigger framework of a front
Sure.
end, right? And we're kind of in Java, and so they're sort of used to it.
I was gonna say
But-
Pygame,
But I mean, you gotta be honest. Like Tkinter is stupid too, and I mean,
It's
Python's
true.
fine. It's
What?
You know,
All
baby
UI front end
steps.
frameworks suck? Okay.
yeah,
Yeah, how about
that's
that?
it. That's it.
it does what you need it to do, and yes, people that are better at it can get better at it.
Because I tried Ember, I tried Vue, I tried React. I mean, it's all sucky, and I
See
It's
that's why
because
you
it's
gotta
all-
do everything in the terminal, Adam.
right. That's why I do it. That's
So
why I do.
So
it.
for example, I do my layout algorithm and I made an ASCII print version of it so that I could see the darn thing.
yeah,
has
so you know what's going
Variable with columns and
on.
only prints off the portion that's visible, so it ignores the pieces that are too big or too small.
Yeah.
We were also trained, I say trained, to debug with print statements in code rather than use the debugger a lot of the time too. So
Well, there's
Yeah,
that.
that was I'm gonna say it's John's fault because I debug like John does, like
Yep.
straight up. Like he was sort of my guru on that side of it because he taught me C, So
mhm.
I mean, in the debugger. Now again, we went into assembly with Matt and he taught us GCC, right? So we
Mhm.
learned how to
GDB,
debug
yeah.
or GD. Sorry, not GCC.
GDB, yeah.
GCC is the compiler. GDB.
Gnu
and
debugger or something. I don't know.
Yeah. Which is great, and I actually use GDB
Oh,
a
GNU
lot.
debugger DB. Yeah.
Yeah,
Sorry,
debugger, DB.
brain tangent. Yeah.
And I use it a lot, but still, I mean, the way you do it first is the way that you develop your habits. Right. So even
GDB also is like an assault on the eyes. Like if you're, it just,
Well, if you
GDB,
use, if
when
you
you're
use
doing
GEF,
assembly
GEF,
language, though,
it's pretty
like,
nice.
it was
Okay,
whatever
what-
we used on those old brick laptops. I don't remember.
so what did you say, Matt? What's nice? GDF?
GEF.
GEF.
So it's
GEF.
a colorized version of
GDB.
GDB that shows you like where your code is and all the registers and
Whichever
stack and-
plug-in for VS
So-
Code.
If you're
is what I use.
colorblind, if you're colorblind, would it look any better?
Yeah, I mean, so the
Let's
nice
not
thing
get too
is-
crazy.
So Adam, when you step over an instruction, it prints off all the registers. It prints
Oh,
off
nice.
what ESP points to and down the stack
So-
a little ways.
I was just gonna say, I've used
Shows the
stack too.
current-
Yeah.
listing
'cause the
of
stack-
instructions.
The
I'll send
stack
you
is
a
one of the
link.
things that, please do,
Yeah.
because I use GDB, and there are things about it that I don't like the stack, for instance. Like I
just
like knowing.
thought of a great, like, kind of a change to an assignment for either 180 or 330. So if they ever want to do a recursive factorial or something like that, make them write the code that prints out the stack each time it does an operation,
time it goes
so
through,
they can
right.
visualize what's happening.
What's happening on the stack. Yeah, because currently, like when I'm teaching how to use GDB, I just make them print off the stack space, right? Or some portion of the stack space. But it would be nice if it was more intuitive than having
Yeah.
it to do it that way, right? Like it's really good. It's really nice the way that the registers are represented. It's really nice the way all that, but like I want to know what's going on in the stack because
Mhm.
so many times it's a stack issue that gives you your crashes.
Well, and a
right?
lot of the IDE, well, just IDEs in general will give you, their debuggers will give you the call stack, but they won't
Right.
give you the stack.
Yeah. Well, and ultimately, like with the call ret, I mean, and sometimes you jump and then you're doing a ret, and so you're retting onto an instruction address that's not actually an instruction address, and then you get your ubiquitous segmentation faults. And if you could just watch your stack as you're jumping through the instructions, it'd just be so much easier because it's like,
Well, then you
oh,
gotta,
I see what
you
happened
gotta
there.
go
I'm
grab core files and do traces and stuff. Like
right, right. And so doing something with a little bit more of an intuitive stack representation would be really, really, really nice. Because then even color-coded stack representation, right? Because when we redefine our stack frame, it'd be nice to be able to sort of see what I'm doing locally as opposed to going back out and what the whole stack looks like and blah, 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 blah. So I want to play with GEF and see if that's better.
Oh,
So-
it's definitely better. But
Uggsy GEF.
I mean, it sounds like it.
Sounds a lot better to me.
well,
So,
So,
I'm still,
have you been paying
nano
attention
days.
to the changes in optical storage that have been happening lately? They're bringing it back.
What? I haven't been paying attention.
So,
I've been
I think there was a
fishing too
couple of
much.
years ago there were some breakthroughs, and then more recently, they're fitting hundreds of terabytes onto optical discs now. Just
Onto a
because
CD?
They're well, I don't know if it's CD
Or
or
is it
DVD
DVD?
or what the actual, but it's finer lasers, and they're making the discs thicker, and it's multi-layering.
Oh,
see,
geez.
eventually
So-
we're gonna have memory cubes. Like that's
Yeah,
what
I
we
mean,
are.
well,
Yep.
this had an interesting, and this was back in like 2022, I think was the article that I was looking at.
Memory
It had an
cubes.
interesting anecdote that like something like 80% of data storage is archive storage, which of course, because
Mhm.
all of the data that we created before is greater than, well, I mean, we are creating data at a faster and faster rate, but yeah, anyway,
all the data created
80% is
before,
archive.
right.
Yeah.
Right. All the data created before has to be greater than data we're creating currently because we're creating data from the data that we created before, right? The domain
Yeah.
of data, like it just mathematically can't.
You and your metadata.
Yeah, like you're creating data out of the data yeah. So like
But
the whole
anyway, that's
domain of data.
that's what they're trying to advance it for, is to more efficiently store archive stuff.
Right. Like a memory cube. Like it makes sense to have a lattice work of storage, right? Of
Yeah.
multi-layer. Like it totally makes sense.
Three-dimensionals. That's as
Three-dimensional
efficient as you
storage.
get.
Right. Well, and you can compact it so much closer.
Well, it's the muscle size versus strength argument, the surface
Right.
area of the muscle versus the three-dimensional
cross-section.
mass, or
Yeah.
you know. So yeah, I don't remember what it was, like 4 times or something. The volume scale is like 4 times more than surface area does, or
You guys heard about the people who are trying to store information in DNA, right?
No,
how
but
they
it
could
sounds
s-
terrifying.
also
'cause
have
it's like
viruses and
modifying
DNA,
DNA.
yeah.
See,
Well,
Lisa,
they were
we got
using like the
topics for next time.
yeah, the DNA substructure. Yeah, we'll talk about the next and how much information you could store in the DNA substructure using the DNA Pepto-Bismols or whatever you call them,
Peptides.
peptides.
Well, so what was it?
By the way, everybody, I am not a doctor. I'm I'm a wannabe computer doctor. Not yet that, but I've definitely
So,
done it.
and I found this really interesting because you can actually do the combinatorics math about it. Of all the possible protein and gene combinations in human
Mhm.
DNA, you can
Mhm.
find out like what is the capacity for a species, like
Yes.
what is their maximum capacity. And I just looked it up. For humans, let's see, that's million, billion, 70 trillion, 368 billion. So that's the max number of people that could ever like that. That is the the maximum number of
combinatorics. Right.
combinations of genes. And then when you start to think about it, so the odds that that you were born as you is 1 in 70 trillion.
Right.
It's
Or
just kind of neat to
100%.
think about.
So like 1 gram of DNA can store up to 455 exabytes of data. Like think about that.
Can you remind me on where's that fall? Like petabytes and then exabytes, or
Uh,
because I don't remember.
Yeah, but I think we can
it's
store a full genome in like a gig of a person.
right, and they're
That's
talking
true,
about
yeah.
going backwards and maximizing. We're like when we store the genome, we're trying to
It's
efficiently store
1,000
it.
petabytes. Yeah.
1,000 petabytes. There you go. Which I mean, again, and DNA as a not as a messing with human DNA, but more as a storage, like a design medium,
Right.
right? Like storing it in the form of DNA as opposed to like taking human DNA and saving information.
Changing someone's DNA so it stores information.
But what's interesting though is DNA is informative, and I think Matt and I have had the conversation before about like nature versus nurture. And if DNA is information, then every single species does pass information from species to species. So there is some inherent information passed from A to B to C to D.
Well, I mean, yeah, you can see some instinctual behavior in some
Right.
species, even when they're separated from their species.
Yeah, I think Matt and I talked. Well, that was you and I, right? That we're talking
Yeah.
about a horse being able to stand up, like
Or a
as
human
soon as
being
it's
able to
born.
breathe without thinking about it.
Mhm.
Right, a human being able to breathe, right? So there is core programming, like if you were to call it that, based in the DNA of a species, right? But what's interesting is the core programming changes over time and sort of the adaptation, and like horses obviously need to be able to walk quickly or they die, right? Like that's something that needs to happen. Humans
Herd
have to be able to
animal.
breathe as soon as they get out of the womb, right? Because otherwise they die, right?
Yeah,
So
respiration is kind of important.
kind of a big deal, just slightly. But anyway, this is good topics for next time, right? Like
Yes.
this is fantastic.
We're burning too many good things to talk about.
Well, between the three of us, we have enough hot air to probably heat the entire globe and destroy the world. But it's not like
We're
struggling.
we're getting to my favorite time of year. So there's
Yeah.
hunting seasons, there's frog season, there's college volleyball, college football. I'm excited.
Yeah, I'll be in over my head with all of those sorts of things. I can
And
tell you about.
I'll be over my head teaching machine learning. So
Well, there you go. Well, there you go.
Well, I gotta go, guys. So
Yep.
All right. Yep. We'll see ya.
We'll do it again next time. Thanks, guys.
Next same bat time, same bat. Well, kind of the same bat time.
Sometimes the
We'll
time
see you guys.
changes.